Okay, so welcome back Year 9, we're starting Term 2. So for those of you who have not been doing the right thing, there are a number of you. I have been on Google Classroom, I have looked at all your work, I look at it in detail. So don't just upload anything you like, a little bit of last term's work or just the notes or whatever. You need to upload photos of all the work I put on the board, not just the bits you want to put down, and all the homework. Okay, so I'm a bit sick of sending emails to parents and you about this, all right? But if you want to go down that path, I will continue to send emails to parents. So just do the right thing, copy all the notes and examples down, listen to what I'm teaching you so that you do understand how to do the homework, then go and do the homework that's on Compass. Okay, so this is still going on the last topic that we've been on. We are doing scientific notation. It is sometimes called standard form, but mostly it's called scientific notation. The reason it's called that is because it is used a lot in the science world. It's used for very big numbers and it's used for very small numbers. So if you look, for instance, on your calculator, it can only show you a number up to the end of the display. So 99999 as far as the display goes. After that, it can't tell you anything bigger. Scientific notation allows the calculator to be able to tell you bigger numbers than that. And the same with the smaller numbers. So on your calculator, the smallest would be 0.00000, however many places, 1 at the end. This will be able to show you much smaller numbers. We need it in science because in the world of astronomy or big distances, where we're looking at distances between planets, we look at very big numbers. Masses of some very big things, like the mass of a planet and things like that, we need very big numbers, and this allows us to do that. It also allows us to look at very small numbers, so when we're looking at the mass of the little germ that's causing the coronavirus, things like that, we're looking at very small things where we have scientists looking under microscopes, and so we need to be able to express those very small numbers. Okay, so what is it? Scientific notation or standard form has a decimal between 1 and 10, a times sign, and a 10 to the power of a number. So this is scientific notation. 5.46 is a decimal between 1 and 10. It has a times sign, and it has a 10 to a power of something. So the first thing we're going to learn is how to write a number in scientific notation. So this is the steps we're going to go through. We're going to put a decimal point after the first non-zero digit. Then we're going to copy all the other digits down. Don't leave anything out. Then we're going to write times 10. Then we're going to try and get the power that goes on that 10. To do that, we look at the direction and the number of places that we need to move that decimal point to get it back to where it started. That bit's important. So if we are going to the left, it'll be a negative power, going that way. If we are moving the decimal point to the right, it's going to be a positive power. Okay, so in these questions here, we're expressing in scientific notation. So here's our first number, 2400. After you copy down the number, some of you aren't copying the number down and you're working for your homework, copy it down, 2400. Then you're going to write it down again, 2400. With the decimal point on the end, because this number is a whole number, the decimal point would be on the end. So put it on the end. Then you're going to change colours to your red pen. You're going to put the decimal point after the first digit that's not a 0. So this is not a 0. We're putting the decimal point after that. Then we're going to look at where we put the decimal point and see how we get it back to where it started at the end here. We have to jump 3 places to the right. So that tells us, firstly, that our decimal is 2.4. There's no need putting 2.400 because that doesn't mean anything. So just 2.4 times 10, and then we're going to the right with our jumps, so we put a plus there, and we're jumping 3 places, so we put a 3 there. So our answer is 2.4 times 10 to the power of 3. In the next one, we have the number 7.8. Copy it down and copy it down again. Now, we would normally be getting our red pen and putting our decimal point after the first digit that's not a 0. Well, there's the first digit that's not a 0. So I put it after it, and you'll see that it hasn't actually moved anywhere. So we have our decimal to be 7.8 times 10 to the power of 0, because it didn't go anywhere. So it just becomes a 0 up there. All right, this next one, we have 0.035. We're going to copy it down again, 0.035. So we're going to get our red pen and put the decimal point after the first digit that's not a 0. 3 is our first digit that's not a 0. We're putting our decimal point after that with our red pen. And then you're going to, with your red pen, jump that decimal point that's red back to where it was in blue. We're going 2 places to the left here. So because we're going to the left, it's negative. And we're going 2 places, so there's a negative 2 up there. So our decimal is 3.5 times 10 to the negative 2. Okay, the next one, you're seeing how they're used in real applications in the real world. We're expressing each measurement in scientific notation. So they're telling you the world's largest mammal is the blue whale. That's a true fact. And it can weigh up to 130,000 kilograms. That's also a true fact. That's how heavy a blue whale is, the largest mammal in the world. So we're going to write down that number, 130,000. It's a whole number, so our decimal point would be at the end. So now we're going to do what we've got to do. Get your red pen, put your decimal point after the first digit that's not a 0. So after this one, put the decimal point in red, and then jump with your red pen back to where the blue decimal point is. So we are writing our decimal down, 1.3, no need to write all those zeros, times 10, and then the power up the top, we're going to the right, so it's positive. We're jumping 5 places, so it's positive 5. When you give your answer, it's 1.3 times 10 to the power of 5, and you must write your units on the ends because we were talking in kilograms in this question. So we'll come back on the next video and do some more practice.